So for our next speaker, he's also like an ex-LA logician like me, an alumni. He was also the previous community manager before I took the reins. We have Rad. Let's give him a round of applause.
Thank you. First off, I have to say I like this setup.
Yes.
I can just have a guitar. First time I talk in a meetup like this. So, as Stan said, my name is Rad. I'm Radamanthus on Twitter, GitHub, LinkedIn, email. I'm going to talk about background workers, delayed job, rescue, and sidekick. You might know more about this than me. I'm just going to share things I encountered in my day-to-day work at engineering. So, illogical engineering. So, engineering, we do DevOps for our Rails customers. So, sometimes they have problems with delayed job workers or sidekick or rescue. Sometimes they need help in tuning their servers that are running with job. So I'm just sharing my my little knowledge on these things. If I'm saying something incorrectly, or if you want to share more, please do so. First off, what's a brief overview of these three? Are you all familiar with these three words? So, if you have the concept of background workers. So you have your Rails servers, and then sometimes, let's say you have, you want to, you're printing an invoice, you're printing a PDF, the customer wants to download his invoice for the month. So you generate a nice PDF and the customer downloads that. If you do that inside the controller, and it takes 2 minutes to generate that inside the controller, that controller is tied up for 2 minutes. So if you have a 8 GB server running 20 unicorn workers, so that's just 19 workers whenever you generate that report. So if 21 customers do that at the same time, your website will go down, or that server will go down. So you want to do those things inside the background worker. So instead of doing that thing inside the controller, the controller will just pass it off to a background job, and the background job does the work, and then the controller is back and available to do more, process more web requests. So we use delayed job or rescue or sidekick for that. What's common and what's different among the three? So delayed job is, it stores the jobs in a database. Rescue and sidekick, it stores the job in Redis. The nice thing with delayed job is things are simple. No need to set up a separate Redis server. And the not so nice thing there is it adds a small but not insignificant load on your database server. And so rescue and sidekick, they both store the job information in Redis. Redis is like something like Memcache. Another thing that's similar and different among these three is, so delayed job and rescue workers are Unix processes. So one worker, one process. But sidekick is multi-threaded. So you can have like one sidekick worker running 25 threads. So the nice thing there is you can have more jobs being processed for one given server. The not so nice thing there is you can easily overload your server. Like, if you have 4 sidekick workers, 25 threads each, and a flood of jobs come in, that can easily saturate your CPU. Alright, so I talked about. Yes.
Is Sidekick, so you have these multiple threads running, is it a Ruby process? Or,
So you have a worker, that's a Ruby process, and then the jobs, one thread will process one job.
okay, so you have one Ruby virtual machine per task, then one Ruby process per task, per job?
No, I think,
Sorry.
if I'm not mistaken, you have one Ruby virtual machine, and it runs multiple threads. One thread will execute one job.
Oh, so, and those jobs are Ruby code.
Yes.
Aren't there problems with like non-thread, thread-safe code colliding and messing each other up?
Not so much
No?
these days.
Okay, good.
Yeah, I remember it used to be, yes, Ruby is not thread safe, but those were the old days. No one reacted except
Okay, thanks.
Yes, I don't remember those warnings anymore. I remember, I mean, I don't remember getting across those warnings these days. So I guess this, your typical, I think Rails was made thread safe starting with version 3. And I think almost everyone here is working on Rails version 3 or newer. But at some point in the evolution of Rails, it became a non-issue. So you just write code and throw the sidekick and it just works most of the time. So, there. Deployment, again, delay job is a lot simpler. No need to set up separate Redis. Rescue and sidekick, you need to set up Redis. And for all of them, when you deploy new code, you need to restart also. You need to restart Passenger or Unicorn to load the new code. You have to do the same with your background workers. And it becomes, I will talk about it later. So that's deployment. Bloat. This is similar to Passenger and Unicorn. So you have the thing with Ruby is it never really frees up memory. So if you have a VM using up 500 megabytes, and then you had to process a lot, you had to process a file, and the VM grows to 600 megabytes. As far as I know, it will stay there until you kill that VM. Maybe it changed just with Ruby 3, but as far as I know, that's how mainstream Ruby behaves as of now. And so eventually your processor, you start Unicorn. This is also true with Unicorn workers and Passenger workers. So you start loading your code and nothing else. It starts with say 400 megabytes. And then it does some work, it does some work. Eventually it goes to 500, it goes to 600. At some point, if you don't control it, it will use up all the memory in the server. And it will end up using swap, and the server becomes slower and slower. So you need to do something to kill those bloated processors. So you need to do this for all of them, for sidekick, for rescue, for delay job. What we do at Engine Yard is we just monitor them with Monet. Monet has a nice feature where you can specify that if this process hits this certain memory size, kill it, and then start a new one. So how you deal with bloat for delay job, rescue, and sidekick is very similar. You can use Monet or something similar. And this is more important with background workers than with web workers, because the typical use case for a background worker is one typical use case for a background worker is processing files. And so if your worker processes a huge file, then loads, and then it stays at that memory consumption. So you have to manage it. Long-running jobs. So one difference between delay job rescue and sidekick I mentioned earlier is delay job and rescue, the workers or jobs are run inside processes, and with Ruby, jobs are run by threads. Why is that significant? Sidekick is really designed to run really small jobs. Like if you file a bug report with Sidekick that, hey, I have this long-running job and Sidekick misbehaves, the Sidekick author will tell you, break it down into smaller jobs. So when Sidekick was introduced, we all thought, oh, Sidekick's the new thing. It's so they can run more jobs than this old delay job and rescue. But when it comes to long-running jobs, and sometimes, I don't know, it's the nature of your application, you have to do it that way. Sidekick is not so good, and that's why some applications still stay with rescue and delay jobs. So that's one key difference and one, you can say, advantage of delay job and rescue over Sidekick. Although in general, you really want to break down your jobs into small bite-sized jobs as much as possible, be it whether you're using delay job, rescue, or Sidekick. It's just more imperative when you're on Sidekick, because that's the nature of Sidekick. And database connections. So you all know that Rails uses a pool of database connections, and same with delay job and rescue and Sidekick. They will use a similar pool. You don't need, so if you have, sometimes if you have, what do you call this, heavy processes, you have processes that, you have code that holds on to a database connection for longer time than usual. So the typical thing with Rails is you get a database connection from the pool, do some work with the database, and then release it back to the pool. So that way, like 20 or more work processes can share a pool of just 5 database connections. So same with delay job and rescue and Sidekick. But with Sidekick, because you can potentially run multiple threads, you run the risk of saturating your database pool connection more. So, like if you're used to using the Rails default of 5, on some Sidekick setups, you might encounter the error where your job is unable to get a database pool connection because the other threads are using it. Like if you're using 25, I think that's the default for Sidekick, 25 threads. So you might find sometimes that you will run into errors because 5 database pool connections is not enough for your 25 threads. So run on a faster CPU or just increase the pool size.
Since Sidekick is using Ruby threads for this, it's only using one CPU. So do you run multiple Sidekicks, use all the CPUs in it?
So yes, one, if you have a multi-CPU machine, I'm not sure if there's a way to tell Sidekick that, hey, this process goes to this CPU and this process goes to this CPU.
Ruby VM is incapable of using more than one CPU, and so JRuby can, but MRuby can't. So that's why I was doing it.
So you're saying
But you normally just use one sidekick instance?
I've seen setups that use like 2 workers or
I see.
3 workers, multiple threads. But yeah, I guess that's not an optimal way to do it. Oh, that's it. What else? That's it. Do you have anything else you want to discuss?
I'm curious about the database connection problem. Is there no way for a sidekick to communicate whether or not it's ready to offer a database connection to a job so that they can just sit and wait for one to become available?
I don't think so. So sidekick will be just like Rails in this sense, and also I don't think Rails behaves that way. If you have, you can also saturate your database pool by running multiple unicorn workers. Like run 100 unicorn workers probably. I think 5 workers, 5 a connection to a 5 can still handle that thing there. Thank you.